So welcome to Transmission and Switching Systems course. This is our week 6, and in week 6, we are going to study about the classification of switching methods. So far, we have studied different switching systems and switching schemes. But in today's class, we are going to briefly study about the different methods of switching. Now, we have seen, or we are familiar with these topics, but in today's class, we will focus a bit in detail in this topic. So, the outlines for today's class is switching system, methods of switching system. In method of switching system, we will study circuit switching system, packet switching system, message switching system. So basically, we will study different methods of switching system. Now, what is switching system? We have studied what is a switching element. We have studied about switching elements, but now we are heading towards the definition of a switching system. What is a switching system? A switching system is a collection of switching elements arranged and controlled in such a way as to set up a common path between any two end-to-end points. So there may be two endpoints. Now, end-to-end point means the end nodes. Okay, the end nodes or the final devices. So the end devices or end nodes, they can also referred as end-to-end points. Now, I mean no intermediary points. They should be the end points or the end-to-end points. So between two end-to-end points, like this is one end point, this is another end point, or this is a end node, this is another end node. So between these two end nodes, a switching system is a collection of switching elements. Okay, so between these two nodes, there should be some switching, there should be some arrangement or collection, there should be some arrangements of switching elements. So the combination or collection of switching elements arranged and controlled in such a way to set up a common path between two end nodes is known as a switching system. So when we are trying to establish some connection between these two nodes so that they can transmit data, they can transfer data. So that arrangement of switching elements is known as switching system. Okay, so we have studied about switching elements. Now the collection or the arrangement of those switching elements is known as a whole switching system. Now a switching system is variedly known as a switching office, switching center, telephone exchange, a switching node, or simply a switch. So a switching system can also be known as or referred as switching office or switching center, telephone exchange, switching node, or simply it can be called as a switch. Now the subscribers are not connected directly to another. Okay, so the subscribers are not always directly connected with other subscriber. In between them, there can be different switching elements or switching systems. Now, when a subscriber wants to communicate with another, a connection is established between the two subscribers at the switching system by using one or more switching element. I think it is pretty much clear to you what is a switching system. Now, in the figure, we can see a combination of 9 switching elements. There is switching elements 1, 2, 3 to 9. So there are 9 switching elements. So, and these are the subscribers. So this is subscriber 1, this is subscriber 2, this is subscriber n minus 2, this is subscriber n. So when we are trying to connect this subscriber with this subscriber, we can connect them using some switching elements. So this is basically a switching system. So a switching system contains a number of switching elements. Now, methods of switching system. So there are different methods of switching system. Now, these switching methods can be classified or divided into 3 main categories. What are they? Circuit switching, packet switching, message switching. Now, in packet switching can be further classified into datagram switching, virtual circuit switching. So we will study all these switching methods one by one in detailed manner. So first, we will observe circuit switching system. Now, what is a circuit switching system? So it is a transmission mode that establishes a dedicated end-to-end communication. Okay. So what is a circuit switching system? It is a transmission mode that establishes a dedicated end-to-end communication. So there must be a dedicated path between 2 nodes. It is a connection-oriented. This circuit switching system is a connection-oriented system. Initially designed for voice communication. So a circuit switching system was initially designed for voice communication only. Then it was deployed in other communication sectors as well. Now, in circuit switching system, no delay in the flow of data. There is no delay in the flow of data. So, if any application needs minimal delay or no delay, then circuit switching system is a good fit for that application. Now, the use of circuit switching system. So basically in telephone system, circuit switching system is being used. Layers of circuit switching system. Circuit switching system is implemented at physical layer. Now we are studying about different layers of OSI reference model, OSI reference model. And we are being studying the TCP/IP suite. We all know about the different layers of this reference model. So at the first layer is the physical layer. So so far we do not know very detail about these layers or the functions of these layers, but we all are familiar with these 7 layers or 5 layers. Now, this circuit switching system or this circuit switching system is implemented at the first layer, which is the physical layer. Okay, so for the time being, you just know that this circuit switching system is implemented at the physical layer. Okay. Now, there are 3 phases in circuit switching system. So, in this switching system, there are 3 phases. 1 is circuit establishment, 2 is data transfer, 3 is circuit disconnection. So, it seems very obvious that before transferring or transmitting some data, I have to establish the circuit or establish the connection. Now for the circuit establishment, I have to establish, or I have to connect the circuit. So the first phase is, or the first step is circuit establishment. Then when the circuit is established or the connection is established, I will start transferring data. So the second step is data transfer. Now it is very obvious that when my data transfer will be finished, that circuit connection will be disconnected. Okay, so this is the three obvious phases of circuit switching system. Now this is the block diagram of circuit switching system. So in your assignment in this week, I am going to give you an assignment, and in that assignment, you have to draw the block diagram of these different switching methods. So these are very important. You have to draw very carefully and beautifully in your assignment. Okay. So the block diagram of circuit switching system. So this is the block diagram for circuit switching system. Say, for example, there is one local area network, LAN network. There is another local area network, and in between, there are different switching elements. There are different switching elements. So as a whole, they are known as switching system. Now, say, for example, this is our subscriber A, or any user A. It wants to send data to, say, for example, it wants to send data to D. So this is our subscriber D. Now, for the circuit switching system, we have studied, or we have discussed, that there are three phases, or there are three steps. So at first, a circuit connection will be established between A and D. Then the data transfer will be happening. Then after the fulfilling or after the completion of data transfer, this circuit will be disconnected. So this is the basic block diagram, or this is the process of the circuit switching system. Now the advantages and disadvantages of this switching system. So the advantage is, once the circuit is established, data is transmitted without any delay, as there is no waiting time at each switch. Okay, so there is no delay. There is no delay, as I have a dedicated path for my data transmission. Okay, so my data should not wait for any purpose. Okay, so there should be no delay. Now the disadvantages are, link of the communication can't be used to send any other data even when it is free. So say, for example, when this circuit, or this path is established for data transmission. So A is transferring data. Say, for example, it may be happen that A is not transferring data continuously. Say, for example, it is sending data, then it is waiting for 2 minutes, then again it is sending data. So the data is not continuous, it is some in form of bursty nature, irregular nature. So in that case, the time being, this connection is established. This path is busy. This path cannot be used by any other users. Okay, so this path will be busy for that time being. Whether A is transmitting or not, this path will be busy for that time being. Say, for example, in previous days, when we used to talk using landline phones. Say, for example, some other user is calling my number. He or she might get busy because I'm speaking to someone else. But in today's telephone communication system or mobile phone communication system, we have waiting option. So say, for example, I am speaking to someone, and if another person is calling me, she or he can be wait, or he or she can be in waiting list. So I can say, for example, I'm not I can keep the first person at hold, and I can speak to the second person, right? So there is an option of waiting or holding some person. But in the circuit switching system, there is no such option. So for the time being, this whole connection is busy, and the other users cannot use this connection. Okay. So this is the first point, that link of the communication cannot be used to send any other data even when it is free. Now the second problem is more bandwidth is required, as I am having a dedicated path, so I need more bandwidth. Okay. Now connection establishment time is more, as before the starting of data transmission, I have to establish the connection. So I need some dedicated time for this connection establishment. Now the second method, which is the packet switching system. So we have studied circuit switching system. Now we are heading towards packet switching system. So in packet switching system, messages are broken up into small packets. So say, for example, I have a message. That message will be broken into small packets. So I have 3 packets here. So my message will be broken into several number of packets. Now, individual packets take different routes to reach the destination. So this is the basic difference between circuit switching system and packet switching system. That in circuit switching system, the path is fixed. The path is similar for data transmission, but in packet switching system, different packets can take different routes. Okay, can take different routes to receive the destination. Okay, so it is a connectionless orientation. It is a connectionless orientation because there is no dedicated path. There is no dedicated path. There is no dedicated connection in packet switching system. My packet will reach to the destination using whichever path is free. Okay, using whichever router is free. Now, initially designed for data transmission, it was initially designed for data transmissions, and circuit switching system was initially designed for voice communication. Okay, but it was initially designed for data transmission. Now, types of packet switching system. So in packet switching system, we have 2 types. One is datagram packet switching. One is virtual circuit packet switching. See here, the first one is datagram packet switching, and in second we have some form of circuit packet switching. We have circuit switching also, we have packet switching also. So we are in the second method, we are going to have a combination of circuit switching and packet switching. Okay. So let's see the datagram packet switching first. So now the layer of packet switching system. Packet switching system is implemented at network layer. So packet switching system is implemented at network layer. So you have to remember this point that packet switching system is implemented in at network layer. So you just have to remember these points when we are going to study about the functions of each layer in detail. We will study briefly about these points there. Okay, so I'm not dragging those points here. I'm not lengthening this lecture. So you just keep mind this point. Okay, we will study this in our other books. Now, the block diagram of packet switching system. So, say for example, there is one user where this is the transmitter or the source and this is the destination. So, between these two devices, I have different number of routers, different number of switches, different number of routers. So this is the whole switching system. So the packets, say for example, there are two packets. So one packet is moving as packet one using this path, and another packet is moving to this path using this path. Okay, so they are using different paths. So it is possible that packet 2 can reach before packet 1. Okay, so in that case we have to use some synchronization number or sequence number. Say for example, with packet 1 I have to use some sequence number that it is 1, and with packet 2 I have to use some sequence number 2. So when my destination will receive those packets, it will rearrange them sequentially, okay, according to their sequence to get the original message. If it mismatch the sequence, then the original message will not be delivered successfully. Okay, so the datagram packet switching system rearrange has been written here. So rearrange means whenever this destination is receiving the packets, it needs to rearrange those packets sequentially. Okay, like 1, 2, 3. It needs to rearrange them. Okay. So this is the block diagram of packet switching. This is the block diagram of datagram packet switching as well. Now, in case of virtual circuit packet switching, in case of virtual circuit packet switching, what has happened that, let me erase all this. Okay. So in case of virtual circuit packet switching system, this is my source, this is my destination. I have my message is broken into different packets. So this is packet 1, this is packet 2. But when I am, sending these packets before transmission, I will fix some path. Say for example, I am fixing this path. So I will only use this path and I will send my packets in a particular order. Like I will send packet 1 first, then I will send packet 2 second. Okay, so my packets will be transmitted using this dedicated path. So I need to establish a dedicated path before transmission. Then the packets will be transmitted using this dedicated path. Okay, so this is the combination of circuit switching and packet switching. So I am establishing a dedicated path just like the circuit switching system, and I am transferring the data into packets, and I'm sending those packets just similar to the packet switching system. Okay, so this is the virtual circuit packet switching system. Now the advantages and disadvantages of packet switching system. High data transmission in a packet switching is very easy. Okay, so whenever if I have a high data, if I need a high data rate, or if my data rate is high, or if my message is a very big message, then packet switching system is a good fit for me. Then it is increase the bandwidth. It needs increased bandwidth. The bandwidth is higher, bandwidth requirement is higher, and it can actually uh, allow a large bandwidth. If I need a large bandwidth, then packet switching system can ensure me a large bandwidth. Decrease transmission delay. As whenever in packet switching system, the packets can be routed using different routes. So they should not wait for any free path. Okay, they should not wait for any path to be free. So simultaneously, packet 1 will be reached, then within a second, packet 2 will be reached using another route, packet 3 will reach using another route. So, the the transmission delay is very much low in packet switching system. Now, there are some disadvantages also, like high installation cost. So I need different numbers of switching elements or routers. So the installation cost is high. Large amount of RAM is required. Random access memory is required. So large amount of RAM is required. Increased processing power. Okay. So the processing power is also increased in this switching system or in this system. Now the last, message switching system. So in message switching system, the messages are stored from the secondary storage. There is no direct link between the sender and the receiver. Message switching is also called as store and forward network. So the block diagram of a message switching system. Let's observe this block diagram. So in message switching system, say for example, this is my source and this is my destination. Yes, this is my source and this is my destination. So say for example, in a message switching system also, the message from the source, I have a message M1. So this is my message M1. Now M1 will be transmitted from this source to some, say for example, some router or some point or some intermediary point in my network. Now this intermediary point will receive this message M1 and it will store. Okay, so it will store. Then it will forward the message to another router. Now this router will also store, and then it will forward the message to the next router. Now that router will receive the message, it will store, and according to the destination address, it will send the message to the destination. So in message switching system, the message is, the message is not directly sent from this source to the destination. There is no connection established, when a particular connection is not being established between the source and the destination. No, nothing like that. So initially it will be given to some router only. That router will pass that to another router. It may transfer to this router or this router. Then this router will pass that to the next router. According to the final destination address, it will be sent to the final destination. Now, similarly, say for example, this is another source and it has another message M2. Now, it will send the message M2 to this router, and this router will store it and forward it to this router. Now, when this router is receiving M1, so it will, at that time, it will receive M1 only. It will receive M1 only, it will store M1 only. Then after it passes M1 and becomes free, then it will receive M2. So in between that time, M2 needs to wait. Okay, M2 needs to wait. M2 cannot be transferred to this router when it is processing the M1. So M2 needs to wait. M2 will wait. Then when this router is free, M2 will be transferred to this router. So this router will get M2 and store M2, and then it will forward M2 to this destination. Okay, so this is actually the message switching system. So the advantages and disadvantages of message switching system. So the advantages are efficient traffic management. Efficient traffic management reduces network traffic congestion. Say for example, whenever I have a large number of, say for example, if I have a different number of users, so my messages will be transferring simultaneously to different routers, different switches. So all of the switches or routers will participate in the transmission, and this is how the transmission will become a bit rapid, a bit fast. Now the disadvantages of message switching system: some delay due to storing and forwarding. When the router is storing and forwarding, so there may be some delay. Large storing capacity is required. If my message is large, then according to the capacity of that message, the router needs a larger capacity as well. Okay, so this is the end for this slide.